Hey, welcome. All right, in this video, I want to show off an extremely useful tool. And this helps me build footprints like nobody's business. All right. It helps me build footprints very quickly and to IPC standards. So if you're using a table to figure out your footprint sizes and all that stuff, that's great. Based on IPC standards, that's fantastic. But here's this tool that generates the names for the footprints for you, generates the details for the footprints and the measurements to the IPC standards, and also based on updated information since IPC 7351B. This is where you want the most updated stuff. Can you trust this? Yes, because the person who is involved with this, the people who are involved with this are the IPC people. Not all of them, but the primary author for the IPC 7351B, Tom Hausherr, is, I believe, the president of this. I could be wrong, but he's a critical key player in this software, this website. So Tom Hausherr is the walking IPC standard for footprints, especially, and he works here, so you can trust it. All right, and he has new information past the latest standard. Okay, so what we're going to do in this video is generate a footprint, and I'll just show you the process of PCB Library Expert. It's very awesome. And so how do you get this software? First of all, you go to the website pcblibraries.com. You create an account, you go to their download section, and then you download the software. It is cloud-based. Okay, so you download and install it. So let me clarify. You download and install it to your computer, yes, but the licensing is cloud-based. Okay. All right, but the pricing is very affordable. We're talking like $99 per year. All right, per year. The amount of time savings I get working with this tool is like, I don't know, 6,000% that for parts per year. Okay, so yeah. All right, now let's go and make a footprint. Let's make a surface mount component, something like a chip, right? When it says chip, it's talking about capacitors or resistors. We'll make something simple, so click OK. We'll do a demo. So in demo, we'll demo just some standard measurements for a typical capacitor footprint, or in this case, a resistor footprint. You can have resistors as well. Also, diodes, very nice. Diode non-polarized, but we'll go with a capacitor non-polarized. That's a very common part, right? Then in here, we have all our steps. What I'll do is generate this part so you can see it first. We'll do with resistor, calculate. You have to hit that calculate button. And next, we want to click on this tool, and then we have a lot of settings we can do. If you have the professional version of the software and not the light version, uncheck OrCAD PCB Designer Basics. OrCAD PCB Designer Basics is for the light version of the software. I have the pro version, so I'm not going to check this. All right, OrCAD PCB, that's what I want. 17.4 is the version I want, but you can choose other versions. For the output directory, I'll set it to Kirsch, Documents, Cadence, Parts, something like that. Click that. Cool. I will auto-confirm loss of accuracy, place 3D step models via script. Sure, we'll test it out. And then auto-run the batch file, actually. There's a batch file that gets put in there. Excuse me. Well, actually, let me not do that so you can see what I'm talking about. And then for this one, I'll set the vertical axis to Z for the step model. The output directory will be the same as the footprint. So let's go to Cadence, Parts. Click OK. Fantastic. Now, I'll set this as a default format, so I'll check mark that. Can I save entries as preferences? Fantastic. Then create and close this. So it closes the window and it should auto run the batch file. But does it? Unfortunately, it does not. So what I'll do is go to the Cadence parts folder. It generated, look at this. See, it generated the name of the footprint according to IPC naming standards and conventions. Fantastic. I'm going to move this step model into the same folder, actually. Yeah. And then double click. Now what gets generated is a .bat file. The BAT file or batch file is a file that runs your script, two script files here. Each of these script files performs steps to open up and create a pad stack for the footprint, for the resistor footprint. And then once the pad stack is created, it opens OrCAD or Allegro to generate the footprint. The footprint then uses the pad stack that was generated. I'll show you. So let's right click and edit this. And let's see what's going on. Allegro-S. Good. I have Allegro in my system environment variables. If you don't have Allegro in your system environment variables or the folder, you need to go to environment variables. Now you can set it for your system, which I recommend if you can do that. But if you can't, then you can just set it for your user account. You look at the path folder, click edit, you add a new entry, and then you choose this folder. And if you have 17.2, 16.3, doesn't matter. Make sure you choose, well, actually it does. If you have 17.2 with the latest hotfix, then you want to go to 17.2 tools bin and 17.4 tools bin. If you have 17.2, like the old version of 17.2 or previous versions, then you would go to just bin within 17.2 and 16.3, 16.6. All right, but for the latest versions, just do this, right? And then click OK. Fantastic. Now that your environment variables are set, whenever we look for Allegro, it will automatically, like the system will know where to look for Allegro. If you don't do that, you'll get an error. Double click to run this file. Okay, my software opens. Then a new design. Yeah, sure. We'll do the yes. Sure. Don't show again. Click OK. Oh, look at that thing go. Oh my goodness. Look at that. Look at it. Fantastic. Let me open this up real quick. See, it just generated a footprint just like that. You didn't have to do any magic or getting the numbers and then figuring it out and putting the things in there. See, this is our footprint. And now if we do the 3D view, how does it look? Oh my goodness. Beautiful. Look at that. Hold down the shift key and the middle mouse button. Fantastic. Now we don't have like the name of the manufacturer on here and whatnot, but isn't that just better than getting third-party devices and footprints and doing all that stuff? You can customize it just the way you want to. So let's go ahead and save this. Okay, fantastic. That's what I wanted to show you to demo this. Let's go through another footprint, but in this situation, we get into some details. This isn't a full tutorial, but I do explain some things. All right, let's do a through-hole footprint, axial resistor or something like that, right? And then we'll do our demo stuff and hit calculate. It went from the exclamation point to the green dot. When you see the green dot, you know that the footprint is ready to go and that it's good. Let's explain what's going on here. So we have our different types of devices we can make. Surface mount through-hole devices, and then there's a special designer. That's where you really get into making your custom design footprint. But we're going to get out of designer, okay? And then go back to our thing. Let me do demo one more time and get my exclamation point. Pitch was calculated. Okay, let's do calculate. And good. All right. Now, next we have component data. Let's look at all the categories where we can establish here. We have component data. We have terminal density level, pad stack rules, drafting rules for your drawings, and the footprint itself. All right, let's look at this. For the component data, we need to know which family it's in. Is it a resistor? Is it an inductor? Is it a diode? Stuff like that, okay? For the pitch refers to, well, what's the pitch? It's this distance E, this small e here, from pin to pin. The pitch, whenever you hear pitch for a footprint, it's from pin 1 to pin 2 to pin 3, blah, 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 that distance. 11.99 millimeters. How do I know I'm in millimeters? Is at the bottom. If you want to set your units, in fact, I recommend you putting this up at the top, really. Units, millimeters, and then you set it mils, inches, micrometers, blah, blah, blah. All right. Set tab stops for required. This is just as a note, this is its explanation video and a tutorial video. So the tutorial was at the beginning, and this is the explanation phase. But it's also a review, okay, to see whether it's worth working with. You already know how I feel about it. Absolutely, $99 per year. It's fantastic. All right, but I also give some my feedback and my thoughts on the insides of the software. Okay, now for the A. We have, this is what we're looking at. Pin, from the bottom of the pin to the top of the device. That's the A distance. You set that. You set it based on whatever you get from the data sheet. So you open up a data sheet for a part you want to make the footprint for. Of course, that's why you're doing this. And that's how you're doing this in the first place, right? And then you get whatever information you can from the data sheet. A lot of times they only give you the maximum height or the minimum height, which I don't see often. They give you the maximum usually and leave you with that, and they say, hey, yeah, there you go. You put in your required value. That's why that red asterisk is here. There you go. And then a lot of times they'll give you, in the mechanical drawing, the minimum and the maximum, but they won't give you a nominal. They won't average it for you. You have to do that yourself. Well, that's if you're not using this tool. If you are using this tool, here you go. You put in your minimum, you put in your maximum, it calculates the nominal for you. Let me show you. If you put in 60 or whatever, hit tab, then it'll calculate it for you. You have to hit the tab or enter though. I recommend tab. So let's change it back to 63. Hit tab. Good. Notice this dot went red because I've changed some stuff since the last calculation. Anyway, for D, optional dimensions are indicated in blue, but we don't have any optional ones, just requireds. For the D, there's the package body from here to here. Keep in mind, because I make this mistake a lot of times, the letters that are on here take precedence. You have to map the letters. You have to figure out what letters this corresponds to in the footprint drawing, right? It's easy to get confused about that. For D, we set that. For E, this is the thing. You see it, and then you're done with that. Then you have your options. For your options, you have millimeters. For the rest of these things, you can choose whatever you want. But let's say you had a device where you needed a pin 1 orientation for BGA or something. You say where the pin 1 orientation is. But we're not concerned about that right now. For the origin, center of the extents or pin 1. For through-hole devices, set the origin to pin 1. Okay? That's the IPC standard, 7351 standard. For surface mount devices, you want the origin to be, or rather origin. Okay, yeah, this origin, not origin, apparently. You want the origin for surface mount devices to be in the center of the center body or the center body mass. Okay? I forgot the technical term for it. But anyway, pads on the assembly, do we want them to be outlined or filled? This I won't change that. Holes on assembly, no. Well, let's put this as outline. Let's see. Actually, let's put this as filled for the hole, and then for the pads, we'll do it as outline. I like that. Default pad shape round. Pin 1 pad shape square. Fantastic. Let me see. Round, square. Let's calculate this. Okay. It didn't change, but anyway. It's relatively new. It just came out. This new version came out like late December, early January. Late December 2020, early January 2021. So for the 3D colors, let's look at this. See, it generates a 3D model for you. How can it get better than that? You don't have to go to some third-party website and download the 3D model. You can just do it here. Now you can get the ad-free Enterprise Edition apparently. It keeps surprising me. I don't have that right now. And so the image may not reflect all characteristics. That's fine. I'll change it to black. I like black. And then terminal density level. Oh boy, this gets into a whole thing. But look at this. It's a very useful picture here. Actually, I don't know if they already had this in mind, but I recommended this when they were developing this actually. So I'm glad that they put it in here. Very, very helpful when you can actually see what you're doing. Solder mask access. For manufacturers, a lot of manufacturers nowadays, they don't want access for the solder mask clearance. Just leave it as 0. Don't do access. Pad mask access. It's a plus or minus, but really this is supposed to be this is supposed to be percentage. So there's that little thing here. But just pretend it's a percentage. A lot of manufacturers want their paste mask to cover 100% of the pads, so you don't have to change anything. Courtyard to body access. For this number is controlled or ruled by the IPC standard or suggested by the IPC standard. I think I remember it being 0.2 millimeters for 7351 for least size components, but I don't know. You have to check the standard. Courtyard to pad access, so on and so forth. Hole access over round lead. Yeah, you have to check the standard for these. I can explain all these, but it would take forever. Hole access over rectangular lead. No. Minimum annular ring. Okay, look at your manufacturer's information, and they'll tell you for your capabilities. They say they want an annular ring, minimum, some minimum like 10 mils or whatever, or something like that. So how they're defining this though, I would say this is supposed to be 0.2 millimeters beyond the diameter. I think this refers to an excess diameter excess in excess of the pad diameter. I don't know. I have to double check. Annular pad ID excess over hole. Okay, that's fine. Pad to hole ratio 1.5 is pretty solid. This may or may not be the same as what the I7351 standard is saying, but I do know that this is based on the newer information that didn't get into the IPC 7351C yet. The C yet is not released yet, but this was in a presentation by PCB libraries. There's a little bit of information for you on there, and also you can find that presentation by Tom Hausherr. Thermal ID access over hole. Right. If you look at here, thermal inner diameter access over hole versus the outer diameter. The standards tell you what that is. You can leave these as is. Thermal outer diameter to hole ratio. Yeah, don't worry about it. Spoke width 75%. That's pretty good. Wave placement, keep out access over pad. That's for special footprints where they just need to be soldered on a certain way. Talk to the manufacturer of the device and they'll let you know. I usually don't have to touch that at all though. All right, terminal density level is done. Pad stack rules. Let's see. I would leave these alone, honestly, unless you really know what you're getting into. And I would let, when it comes to certain rules, I would let my software, OrCAD or Altium, decide this. So I'll leave that alone. Drafting rules. Silkscreen, outline width. 0.12 millimeters is a good thickness or width for your text, for your lines and all that. Add outline to footprint. Well, okay. Here's another thing. Manufacturers may complain if your footprint, if your lines, your silkscreen lines are thinner than 0.005 of an inch. 4 is the minimum, but a number of them like it 5 and up. So you may want to change this to 0.127 millimeters, right? And 0.127 millimeters for clearance to obstacles. because 0.12 is just shy of 5/1000 of an inch. But anyway, map outline to body maximum. Yeah, it's pretty good. Reference designator height, 1.2 millimeters. Good. Depending on your settings, you know, you may want 1 millimeter for that particular footprint. It's up to you. Add outline to footprint. Yeah. Auto generate pin 1 indicator line. I like that. Just in case we can't see the pad, the square pad. For some reason, this is not square. Pin 1 dot size not to exceed. Okay, it's fine. Okay, let's get into assembly. Why do we have silkscreen and assembly? If you check my other video, it talks about the difference between silkscreen and assembly, where I discuss the details and inner workings of a footprint. But anyhow, this is for assembly components, and this is for the engineer who operates the pick and place machine for your PCB. This assembly drawing. Okay. Courtyard. Courtyard is some space beyond this is pink area. This pink thing right here. And then body and terminal outlines, component line width, blah blah blah. That's good. Footprint. Manufacturer's dimensions. So if you have dimensions recommended by the manufacturer, I mean, if you trust them to have good dimensions, then you can use it, but I don't know. I get on the fence about it. It depends. Sometimes you can't trust the manufacturer stuff. A lot of times you can. And I would say in general, trust the manufacturer's stuff and use it to your advantage. All right, so let's calculate, see how that dot turns green, and then what else do we have here? We have some options. You can do your zoom extents. Let's say I want to zoom only up to here or something. Okay, that's doesn't quite work like I was expecting. Zoom area maybe? There we go. Good. And then zoom extents. There we go. Good. You can pan, you know, rotate, and then drawing elements. So if you want to do symbols or shapes, you can add a round symbol or shape, legend top. Do we want the shape to be filled? Yes. And then the diameter. And then click apply. So how do we know where to put this? So you can move it like that. I like that it moves in real time. It didn't used to do this before. Oh, and look at that. It puts it right at the origin. Use the F2 key to capture a location from the mouse before opening this form. Fantastic. And then there's the centroid, you know, if you want to do that there. All right. And check this out. This is Tom Hausherr. Yes, the CEO of PCB Libraries. He is the walking IPC standard, the primary author for IPC 7351. And keep in mind that the 7351 is written to adhere to the IPC J1 standard. Or IPC J standard 1. Okay? But anyway, get in contact with this person. You may or may not be able to reach him because he's busy, but you know, worth a shot. Click done. Oh, I didn't hit apply, did I? Let's do it. And that's my coffee in the background. It's decaffeinated, so what's the point, right? But anyway, so if we do our centroid, let's see, filled shape, and I want it in the center, click apply. Very good. Will this get done? I don't know. I guess I'm doing it wrong. But anyway, you can print your footprint. You can manage the pad stack. Now the pad stack designer on this thing is quite good, I gotta say. But PCB Editor has its own pad stack designer. So does Altium. They're also very good. And if you're going to be any kind of ECAD software, you need to have a good pad stack thing. A lot of them are pretty good. Offset is only... There's a whole... I can make a whole video about this. Let's not worry about it. This is where you define your pad stack. So, yeah. And then You can add your footprint to a library. There's a library that comes pre-installed with this version of the software. And then you can save your library and all that. It's very nice. And then you can move your footprint to the designer. Let's say you want to add additional information. So if we go into designer, right? Can we move this in here? No. Designer. You can add things in there. Clear and reset. No, not doing like I was expecting. Anyway, let's go back to it. Do our demo. Got our demo stuff. Do calculate. There we go. Now we go into build a footprint. And here's some detailed options. I have OrCAD PCB. Is this the only one you can do? No, not by any means. You can do Altium, Eagle, KiCad, Zukin, all kinds of software. It's endless. You need to get a cloud license for the particular one you want to use, though. All right. And you can only use one at a time unless you have the cloud license. Like if you're doing the free version for the cloud, I think there is, then you can only choose one per day or something like that. All right. And can only work in one at a time. But if you pay for multiple ones, you can use the multiple. All right. So now for the version, all the way back to 15.7. They don't have version 10 in here. That's fine. I hope you're using beyond 16.5 at least. 16.6 up to 17.4. We have our output directory. The name, the package name is automatically created based on IPC pre-C, IPC 7351 pre-C standard. That's what I'm going to call it, because there's some updates for the naming convention post B standard that haven't, but C isn't out yet. So run scripts in background. I do not recommend this as far as I know, because you could have a window, you could have a prompt waiting for you to confirm something, but if it's in the background, you can't know for sure. You can't know when to hit enter or something. So leave this unchecked. Auto confirm loss of accuracy, yes. That makes the process go much easier. If you have this unchecked, whenever it's generating the footprint and it asks you to confirm loss of accuracy, you have to click OK each time. You walk away from your computer, you don't do it, you think it's generating footprints for 3 hours or something in a batch run. No, you don't get one footprint done. So I leave this on, I leave that checked. All right. Place 3D step models via script. Yes. Auto confirm SSM save. Sure. Auto run batch file. I'll try it, but it doesn't work. Truncate long names. Yes. If you have the pro version of OrCAD, leave this unchecked. If you have the light version of OrCAD, check it. 3D model. Yes. Check mark. It's hiding over there. I don't know why it's hiding. No probe. No, that's fine. Then what is no probe? No probe means that you can set a rule that says don't put any test points under this device or around this device. And that comes in handy for like knowing about better nails testing and stuff like that. So, but generally I define that within the software if I don't want certain areas tested. Okay. Vertical axis is set to Z. Oh, right. I kept my same settings from last time. Z for OrCAD PCB editor. It might be Y for Altium. I don't know. TH lead extend. Okay. Use .step. Set your output directory. Use version AP214. Quality, you can set it to high or low. I like high because why not? And then material condition set to nominal if you're working with normal PCBs. High density, least, and whatnot. All right, that was a doozy. Yeah, so we'll save entries as preferences and then create and close. Now it might still prompt me or ask me to confirm something. Let's do no. No. Please note that a new is available. Yeah, sure. So this OrCAD is talking about a new 3D mapping function, and that just came out like what, January to 2021. It's very, very new. So there are two ways to map 3D models in OrCAD now. Let's go to the footprint that was created with the ResAD. I'm going to move these components in here. I don't think I have to do that, but I just do it each time. Great. Now if we open up the footprint in PCB Editor, let's take a look at it. Beautiful 3D view. Click OK. All right. Look at that. And it also cuts off the leads so they're not super long leads and all that, like when you download them from the third party, like 3D Content Central or GrabCAD or something like that. Man, just fantastic. Go ahead, close that, click save, yes. Okay, so that was at the beginning of this video, what did you learn? You learned the general procedure to quickly create a footprint and PCB library or Footprint Expert 2021. Now, and then later you learned about all the details of why we're choosing the different options that we're choosing and what they mean. I didn't cover absolutely everything, but pretty much most of the stuff. So now you can run with and do your own footprints and get started with this tool, okay? If you need any help, click on the help section, about, check for software updates, so on and so forth. And there's probably an update for this since I installed this about a few weeks ago. And if you do have any other questions about footprints in general and PCB design, you can hit me up in the comment section or email me. You can shoot me an email and I will get back to you as soon as I can. Okay, thanks for watching. Until next time, keep on designing. Bye.